Good morning, students. Now today we can discuss complex numbers problems. Now problem number 6, the value of I plus I cube plus I to the power of 5 plus up to so on 2n terms. Now number of terms are 2n, means even number of terms in the equation. If suppose take n equals to 1, means number of terms 2. What is the value of I plus I cube? But I cube equals to minus I minus I, that equals to 0. If suppose n equals to 4 terms, here next term I to the power of 5, I to the power of 7. Now 4 terms take it. Now I plus I cube plus I to the power of 5 plus I to the power of 7. I cube equals to minus I to the power of 5 equals to I to the power of 4 into I, but I to the power of 4 equals to 1. Now I to the power of 5 equals to I to the power of 7 minus I. Now that equals to also 0. Any number n equals to take it 0. Now option C is the correct answer. Next, 7th problem. Sigma n equals to 1 to 13 I to the power of n plus I to the power of n plus 1, I to the power of n plus 1. Now here sigma nothing but summation of the series and the values of n 1 to 13. Now first term we get n equals to 1, substitute I plus I square plus n equals to 2, substitute I square plus I cube. Next n equals to 3 I cube plus I to the power of 4 plus up to so on n equals to 13 I to the power of 13 plus I to the power of 14. Now in this I take common I into 1 plus I plus here I square take common I plus 1 plus I cube common 1 plus I. Similarly so on, I to the power of 13 take common 1 plus I. Now in all the terms 1 plus I take common, that equals to 1 plus I into 1 I plus I square plus I cube plus up to so on I to the power of 13. But in I plus I square plus I cube plus I to the power of 4, first 4 terms equals to 0. First 4 terms I plus I square plus I cube plus I to the power of 4. This value equals to 0. Similarly, I to the power of 5 plus I to the power of 6 plus I to the power of 7 plus I to the power of 8 also 0. Up to I to the power of 12 0. Then we get it is equals to 1 plus I into I to the power of 13. Now that equals to 1 plus I into I to the power of 13 equals to I, because I to the power of 13 equals to I to the power of 12 into I, but I to the power of 12, I to the power of 4 whole cube, but I to the power of 4 equals to 1. Therefore, I to the power of 12 is 1 into I, that equals to I minus I plus I square, that equals to I minus 1. Answer is I minus 1. Second option is correct. Next, if n is any positive integer, then the value of I to the power of 4n plus 1 minus I to the power of 4n minus 1 by 2. Require this value. Now I to the power of 4n plus 1 can be written as I to the power of 4n into I. I to the power of 4n plus 1 can be written as I to the power of 4n plus I into I. Next to minus I to the power of 4n by I by 2, because I to the power of 4n minus 1 equals to I to the power of 4n by I. But I to the power of 4n equals to 1. Here it is also 1. That equals to I minus 1 by I by 2. Take LCM, we get I square minus 1 by 2I. But I square equals to minus 1. Minus 1 by 2I. That equals to minus 2 by 2I. 2 get cancelled. That equals to minus 1 by I. Now it is multiplied and divided by I. That equals to minus I by I square. But I square equals to minus 1. That equals to I. Answer is I. Third option. Next, ninth problem. 1 plus I whole to the power of 6n plus 1 minus I whole to the power of 6n. Here given n is odd integer. N is an odd integer. Now see it. 1 plus I whole to the power of 6n. It can be written as 1 plus I whole square whole to the power of 3n plus 1 minus I whole square whole to the power of 3n. That equals to a plus b whole square. 1 plus I square plus 2I whole to the power of 3n plus a minus b whole square. 1 plus I square minus 2I whole to the power of 3n. That equals to, here I square equals to minus 1. Minus 1 plus 1 cancel. We get 2I whole to the power of 3n plus, here also I square equals to minus 1. Minus 1 plus 1 0 minus 2I whole to the power of 3n. But given n is an odd integer. N is odd integer. Now 3n is also odd integer. Any number to the power of odd integer minus of any number to the power of odd integer equals to minus sign we get. That equals to 2I whole to the power of 3n minus 2I whole to the power of 3n. That equals to 0. Answer is 0. First option. Answer A. Next. Root of 2I equals to 1 plus ai, then a equals to, require the value of a, okay. Now root of 2I equals to 1 plus ai given, required a value. Now root of 2I can be written as, here 1 minus 1 plus 2I, here add and subtract 1, that equals to 1 plus ai. Now square root of 1 can be written as 1 square minus 1 equals to I square plus 2 into 1 into I. 2I can be written as 2 into 1 2 into I, that equals to 1 plus ai. Now a square plus b square plus 2ab. Now square root of 1 plus I whole square equals to 1 plus ai. Now square and root cancel, it is equals to plus or minus, just a minute, 1 plus I equals to 1 plus ai, 1 plus ai. Now equate imaginary parts on both sides, therefore the value of a equals to 1, the value of a equals to 1. Next, z equals to 2 minus I root 3, then required z to the power of 4 minus 4z square plus 8z plus 35, required this value. Now given z equals to 2 minus I root 3, 2 minus I root 3. Therefore, z minus 2 equals to minus I root 3. Now, squaring on both sides, we get z square plus 4 minus 4z, that equals to minus I root 3 whole square minus whole square even exponent plus sign. Now, I square into 3 root 3 whole square, but I square equals to minus 1. Now, z square minus 4z, it is equals to minus 3. Take left side, 4 plus 3, 7 equals to 0, this value. Z square minus 4z minus 7 equals to 0. Now, here the given expression required the value of z to the power of 4 minus 4z square plus 8z plus 35 plus 35. The value of z to the power of 4 minus 4z square plus 8z plus 35 value required. Now, it is divided with z square minus 4z plus 7. How much you get? First to z square multiplied z to the power of 4 minus 4z cube plus 7z square, 7z square. Now, subtract minus plus minus, that equals to z to the power of 4 cancel, 4z cube minus 4z square minus 7z square minus 11z square plus 8z plus 35. Now, here 4z cube multiply with 4z, 4z cube minus 16z square, 16z square, next to plus 7 into 4, 28z. Now, subtract minus sign plus sign minus sign, that equals to, it is cancel, that equals to 5z square minus 28 minus 20z plus 35 plus 35, next plus 5 multiply with 5, 5z square minus 20z plus 35. Now, remainder is 0. Now, therefore, the given expression equals to z square minus 4z plus 7 into z square plus 4z plus 5 are the factors of given expression. If suppose any number plus here remainder is 0 plus 0. Now, if suppose 25 divided with 6 divided by 6, now 4, 24, remainder is 1. Now, it can be written as 6 into 4 plus 1, 25 equals to 6 into 4 plus 1, means divisor into coefficient plus remainder, but remainder 0. Therefore, the given expression equals to this value, but here z square minus 4z plus 7 equals to 0, this value is 0, 0 into something 0. Therefore, the given expression value equals to 0, given expression value 0. If suppose some remainder, if suppose remainder is not equal to 0, some value we get. Now, it is here we get this value becomes to 0 and remainder we get. In that substitute z equals to 2 minus I root 3, we get the required value, we get the required value. Next, if x plus iy whole to the power of 1 by 3 equals to a plus ib, require the value of x by a plus y by b equals to x by a plus y by b equals to. Now cubing on both sides. Cubing on both sides. Left side cube and cube root get cancelled, x plus iy equals to right side a plus ib whole cube. Now a cube plus b cube nothing but ib whole cube plus 3a square b 3a square ib plus 3ab square 3a ib whole square. Now x plus iy equals to a cube. Here I cube b cube, but I cube equals to minus I, because I cube equals to I into I square, but I square equals to minus 1, that equals to minus IB cube. Next plus 3a square bi. Here I square equals to minus 1 minus 3ab square, 3ab square. Now x plus iy equals to a cube minus 3ab square minus 3ab square. Next in these two terms I take common, plus I of 3a square b minus b cube minus b cube. Now equate real and imaginary parts on both sides. Equate real and imaginary parts. We get here real part equals to x equals to a cube minus 3ab square, or x equals to a take common a of a square minus 3b square. Therefore x by a equals to a square minus 3b square. It is considered 1. Similarly, equate imaginary parts. Equate imaginary parts. Y equals to 3a square b minus b cube. Now y equals to b take common 3a square minus b square. Y by b equals to 3a square minus b square. It is second. But require the value x by a plus y by b. Add 1 and 2. 1 plus 2 equals to x by a plus y by b. That equals to, what is first one, a square minus 3b square plus 3a square minus b square. Here 3a square plus a square, that equals to 4a square minus 3b square minus b square minus 4b square, or that equals to 4 of a square minus b square. 4 of a square minus b square is the answer. Now option is four of a square minus b square, fourth option, D. D is correct answer. Next, the real and imaginary parts of a plus ib whole square, a plus ib by a minus ib. A plus ib by a minus ib whole square minus a minus ib by a plus ib whole square. Required real and imaginary parts of this complex number. Now take LCM. How much you get? Denominator a minus ib whole square into a plus ib whole square. A minus ib whole square into a plus ib whole square is LCM. Now numerator we get a plus ib whole to the power of 4 minus of a minus ib whole to the power of 4. A plus ib whole to the power of 4 minus a minus ib whole to the power of 4. Now that equals to numerator. From binomial theorem expand a power 4 plus 4c1 a cube ib plus 4c2 a square ib whole square plus 4c3 a ib whole cube plus ib whole to the power of 4. It is expansion of a plus ib whole to the power of 4 minus of, similarly second one expansion, a power 4 minus 4c1 a cube ib plus 4c2 a square ib whole square plus minus 4c3 aib whole cube plus ib whole to the power of 4 whole by a plus ib into a minus ib, a square minus ib whole square because whole square is there for both. Now that equals to, here we get here plus a to the power of 4 minus a to the power of 4 cancel. Similarly, this second term cancel, fourth term also cancel. Now that equals to, here 4c1 a cube ib, here minus of minus plus means 2 times, but 4c1 value, the value of 4c1 equals to 4, 4c3 equals to also 4, 4c3 equals to also 4. Now here minus of minus plus, here 4 a cube ib, that equals to 8 a cube bi, these two terms. Next to these two terms equals to also plus 8 a ib whole cube by a square, I square equals to minus 1 minus of minus plus b square whole square, that equals to, here I cube equals to minus 1, that equals to, we get 8 a cube bi minus 8 a b cube I by a square plus b square whole square, that equals to 8ab take common in numerator, how much you get, a square minus b square by a square plus b square whole square of I. Now here there is no real part. Now real part equals to 0, real part 0 and imaginary part 8ab of a square minus b square by a square plus b square whole square. Now which option? Real part is 0, imaginary part 8ab of a square minus b square by a square plus b square whole square. Then third option is correct. Next, ninth problem. The integral solution of 1 minus x, 1 minus I whole to the power of x equals to 2 power x. Now here given options, x equals to 1, x equals to minus 1, x equals to 2, x equals to 0. Now verify options. If suppose the x equals to 0, 1 plus I whole cube, 1 minus I whole to the power of 0, any power 0 equals 1, 2 power 0 also 1. Therefore, fourth option is satisfied. Fourth option. Next, 15th problem. 1 plus x by 1 plus I by 1 minus I whole to the power of x equals to 1. Require the value of x. 1 plus I by 1 minus I whole to the power of x equals to 1. Now, in LHS, 1 plus I by 1 minus I. Now, multiplied and divided by denominator conjugate means 1 plus I by 1 plus I whole to the power of x equals to 1. Now, numerator 1 plus I whole square by denominator a minus b into a plus b, a square minus b square, 1 minus I square, whole to the power of x equals to 1, whole to the power of x equals to 1. Now, that equals to 1 plus I whole square, a plus b whole square expand, we get 1 plus I square plus 2I by denominator 1 square 1, I square equals to minus 1, minus of minus plus 1, whole to the power of x equals to 1. Here I square equals to minus 1, minus 1 plus 1 cancel, that equals to 2I by 2, whole to the power of x equals to 1. Now, I to the power of x equals to 1, I to the power of x equals to 1, but compulsory x is multiple of 4, x is multiple of 4 integer. Now, therefore, x equals to 4n, x equals to 4n, where n belongs to natural numbers. Now, fourth option is correct, option 4. Next, z equals to 3 minus 4I is turned 90 degrees in anti-clockwise direction, the new position of z, new position of z. Now, if suppose it is origin, consider the point z. What is z? 3 comma minus 4. It is rotated through an angle 90 degrees in the anti-clockwise direction, anti-clockwise direction, here 90. Now, if suppose here z goes to some z dash, therefore, z dash equals to z into e power I theta, but theta equals to 90, it is nothing but theta is 90 or pi by 2, that equals to here z nothing but 3 minus 4I. Now, you know, in last class we discussed cos theta plus I sin theta equals to e power I theta, e power I theta, but here theta equals to pi by 2, that equals to cos pi by 2 plus I sin pi by 2, e power I pi by 2 equals to cos pi by 2 plus I sin pi by 2.